So welcome everyone to the Data Science / R Meetup. I see a few familiar faces and also a few new people. So my name is Szilard. I'm the organizer of this meetup and I'm also the speaker. So I'm just going to introduce myself as a speaker, especially to those who are joining now for the first time. I did long time ago a PhD in physics and then worked in finance. And 20 years ago, I switched to data science / machine learning, analytics, data, and all those things. I founded this meetup, the R Meetup, in 2009 in Los Angeles, and then later data science meetup in Los Angeles. But now this meetup became basically online. And today, I'm excited to talk about my favorite topic, which is gradient boosting machines. And the question arises, are they still relevant with LLMs and ChatGPT taking over the world? Are GBMs still relevant for machine learning or not? So I want to discuss this in this talk. And of course, everything I'm saying here has nothing to do with my employer. And I usually start my talks with this slide, which I used to mock it, not that much anymore. So this is the famous slide from Andrew Ng from 15 or so years ago, in which he says that basically deep learning is beating every other machine learning algorithm. You just need enough data. And of course, okay, someone started. I think I see some kind of lately. I heard that it's kind of a problem, but I didn't know it's to this extent. Anyway, so yeah, I think we lost about 10 minutes, but we can catch up. So I was thinking about talking for about maybe half an hour, 40 minutes, and then open for questions. So which will be harder with the this unmuting, but we'll figure it out. So let's get a bit back to traditional machine learning. So traditional machine learning existed since the 90s. KDD was one of the main conferences, and there were many machine learning algorithms that were used since the 90s in businesses. Fraud detection, which I've been working on a lot, credit scoring, manufacturing, insurance, marketing analytics, and all that. And most of those were done with tabular data, which are basically data most businesses had, data stored in a relational database where it has rows and columns, and then there is the relation between these. So about 10 years ago, I was wondering when deep learning starting to get into hype mode, that if deep learning could match the random forest gradient boosting machine and those traditional algorithms that have been used on this tabular data. And it seems like it was hard to tune deep learning neural networks in a way that would beat gradient boosting machines or random forest. And this became kind of more known a little bit later. Here is Tianyi Chen, who was the author of XGBoost and also expert in deep learning. He talked about that a lot of Kaggles, especially those with tabular data, were won by using XGBoost. And here I was at that time, I was very skeptic about whether deep learning will get us anywhere close to AI or will ever beat gradient boosting machines. And also many others were expressing the opinion that for tabular data, gradient boosting machines are the best. And also in of the many surveys I did at the time and a bit later on as well. So actually, the fact that gradient boosting is so good is not that surprising. So there were papers even in 2006 that were showing that random forest, neural networks, gradient boosting machines, super vector machines, they were the top accuracy algorithms. And indeed, I started using random forest in GBM around that time, 2006, 2007. Now, the question is with LLM and that kind of deep learning, can these beat gradient boosting on, let's say, tabular data? So, and there are a lot of implementations of various deep learning approaches and tricks that are adapted to tabular data. This is some of them, and there is a good research paper that came out in 2022 that compared all these methods on a lot of different data sets to gradient boosting, random forest, and the more traditional learning algorithms. And the conclusion was that XGBoost and the other boosting algorithms were still beating these deep learning tweaked algorithms. And of course, what we knew for long that what matters in machine learning is not necessarily just the algorithm, but also data cleaning, feature engineering, hyperparameter tuning, and the use of ensembles if you want to get top of the line accuracy. And this whole data science process of collecting the data, exploring, visualizing, cleaning, transforming the data, and then modeling. So this is all that matters, actually almost more than just which algorithm to use. So with garbage in, garbage out. So if you don't have clean data, then you're not going to get good results. And ultimately, most of us work in a company, so your boss wants results measured monetarily, so they don't care about which tools you are using. So what I think you should do is use always the best tool for the job. So whether if it's deep learning or gradient boosting machines that use the tool that's the best for that given job. So the question is that now with ChatGPT, is there any way that ChatGPT could beat gradient boosting machines? So if you actually ask ChatGPT which are the top 3 algorithms that are the best expected for predictive analytics on tabular data, actually the top one will be always gradient boosting machines. So of course, ChatGPT incorporates the kind of the common domain knowledge over the internet about, mostly of it comes from Kaggle's, where people were discussing in depth that how good GBMs are on tabular data. So that's why ChatGPT is giving you this answer. So what is exactly gradient boosting machines for? So for some of you who didn't get to know very much what GBMs are, here's like a 5-minute overview. So it starts with decision trees. So decision trees, they are like splitting the space into various parts, and then this is how they make the different predictions. And for example, here is such a tree for detecting spam. So this is learned from the data, both the nodes and also the splits. So the splits are by variables. So if variable is less than some value or greater than value for numerical variables, for character type variables is whether it's one value or not. And then if we have decision trees, then we can so-called boost them, which is an enhanced classifier. So the very first boosting algorithms were building trees successively, and in each tree was trying to correct the errors made by the average of the previous tree. So this is how you would add new trees to the ensemble. And then gradient boosting algorithm is a little bit more difficult and more time consuming to explain. There is this wonderful book of Hasty and Tipshirani, which I suggest if you want to look into to really understand these algorithms, then I think that's one of the best books that explain this. So basically it has to do with the gradients. Now the question is, what implementations should we use if we want to use gradient boosting? And here are many of them available. I like open source because it's free. Also, there are Meetup communities where you can meet people, ask questions. There are tons of books. Open source has become in the last 10 to 15 years probably beating the commercial products in at least in the machine learning space. And then many of these have R packages, Python, so it's very easy to use in either one of them. And I started this benchmark project in 2015 when I looked at the various implementations. I was basically interested in which one can run in the memory I had at the time and in decent time. And then uh, it's a bit obsolete, so there are these kind of graphs in comparison. So I will just give you the gist, which is true even now, is that the best ones were both in memory usage and speed were XGBoost, H2O, and around 2015, and then later LightGBM, 2017, open source by Microsoft, and then XGBoost. So all of these are available from both R and Python. And then the question arises that how about big data? Would this work with big data? So most people don't have what big data meant at the time, that it couldn't fit in the RAM of one computer. So surveys also show that most people didn't have big data, or now they have even less because memory has increased much faster than the data set sizes. So big data was present more in like raw data, but for machine learning, usually you have to distill it. So you don't do machine learning on clicks, you do machine learning on user features. So, and that is not that big. So usually it fits into RAM. And even at the time, 100 gigs of RAM was widely available. And now you can have much more than that for very cheap. And still a lot of people were fine with just like, most people do machine learning on 32 gigabytes of memory or even less. So what people want is not bigger machine learning to work on bigger data, but to work faster. And fast is really needed because we do cross-validation, we do hyperparameter tuning, so you run many models. You do ensembles where you combine all these models. So that's why we need to be able to train fast. And after a while, I created this more streamlined benchmark projects where I looked only at the top GBMs and benchmark them. And also it's Dockerized, so it's easy to rerun it or reproduce it. And the top three that came out here as well is XGBoost, LightGBM, and H2O. The top, and they are also the top used. And they've been the top used and are still the top used. So I've been doing these surveys from time to time. I think it's still the same. I think last time I did it was like maybe 2 years ago. So XGBoost, LightGBM, H2O, and XGBoost. And they are the most used because they are kind of the best. So XGBoost, LightGBM, they are the fastest on the CPU, and XGBoost is the fastest on GPU. And then also, if you look at memory efficiency, then LightGBM uses the least memory, and on GPU, XGBoost uses the least memory. So they go kind of hand in hand. But I still like H2O because it's very easy to create like a RESTful API with a few lines of code. So this is basically all you need to have like up and running a service that you could send inputs, and then it will send through HTTP responses. It will send scores. But using it is using all these libraries is very easy. It's usually one line of code, the training, and it's just that it has a lot of parameters, like the most important, the number of trees, the depths, and the learning rate. There are tutorials to learn how to use, how to tune GBMs, and this would be some kind of summary table. So I think if you want to do the fastest learning, then XGBoost, like GBM. If you want easy deployment, then H2O. And it's still the way to get the maximum accuracy. So the classic approach is that you do some exploratory data analysis, then you train some GBMs, and then you combine them into an ensemble to get the best solution. So now the question, what does ChatGPT suggest? Is there anything new? So I asked it to do machine learning on credit card transactions, like a CSV file, and it came up with a lot of reasonable suggestions. So it's really very useful for this kind of brainstorming or seeing if you missed anything. It gave a really detailed answer. For example, these obvious things like how to split, that you need to split your data into train and test and so forth. And also that you need to do data cleaning and feature engineering. But most importantly, so what did it suggest for machine learning algorithms to use? So it suggested exactly gradient boosting machines. So it suggested LightGBM and XGBoost and also CatBoost. So this is what ChatGPT 5, I did this a couple of days ago, is suggesting right now. So, and it's kind of obvious, as I already mentioned, that uh, it's been trained basically on all the mentions of which algorithms are the best for tabular data, which is mostly comes from Kaggle forums and similar sources. So it's not surprising that it's gonna have the kind of the common wisdom of the people who wrote about these things. It also generates some code. So if you ask it to generate code, it will generate the code. As you can see, it's using Python and it's using the LightGBM package. And then also it has these parameter values that it's gonna generate. So then I was trying to provoke it a little bit and ask it why it's using traditional machine learning, why it cannot just go ahead and learn from the data, from the CSV file, and then do its LLM thing in scoring new transactions. And basically, it says that for this kind of data, like millions of structured tabular data, uh, like it's expected that gradient boosting machines like LightGBM, XGBoost, CatBoost will be better than LLMs. And then I also ask what are the top 5 machine learning algorithms that are expected to give the best accuracy on tabular data, and it spits out LightGBM, CatBoost, XGBoost, random forest. So indeed, random forest was kind of before GDMs. GBMs got so great on like smaller data sets when memory was smaller and then the GBM packages weren't that mature, then random forest was kind of the best. And indeed, if you have like 10,000 uh, records in your data set, probably even now random forest is competitive. And then a bit later on, GBMs like 100,000 data sets with 100,000 records, then uh, GBMs will beat uh, random forest. And then it also mentioned TabNet, which we discussed before, but TabNet is good for like very small data sets and it's very slow. So I think the conclusion is still that if you have tabular data, then you should use GBMs. And here are some of my GitHub repos, so you can see more information if you're interested. And the question arises, so we have all these tools, OpenAI, GitHub Copilot, Cursor. The tools they just keep coming. The progress is very fast. So the question is, where are we getting into? So what's the future? So I don't know. The only thing I know that there are more changes ahead. So will we get AI? I don't know. Will this AI be something very good or very dangerous? I don't know. It's just that what's sure that the progress towards general AI will continue, and these tools will get better and better and do more and more crazy stuff. So so far, you can think of them as enhancing your productivity, but we're really at the point where they will really replace. The only thing we can do now is learn. So, and then we'll see where we are getting to. I have no idea. So here's my contact, and I think now I would open for question, but I don't want to. I'm not sure if I should unmute. Let people unmute, or you guys just ask question in the chat. So let's ask. Oh, the chat is also a little bit spammed, but anyway, probably still better than. Let me see in the chat. So ask question in the chat. We still. Oh, I think he's gone. So I mean, if you guys, I can try to unmute. Let me see if I can change that. I can try to. All right. So let me try to change it back so that people can unmute themselves and ask question. Oh, I see some people in the waiting room that I know by the name, so I'm just gonna admit. So let's see. Allow participants to unmute themselves. All right. So you guys can unmute yourself. So please ask questions. Or write in the chat if you still cannot unmute.
Yeah, I made a comment over there saying that, hey, these large language models or these AI models, they have with agents, they will be able to do what we are doing as data scientists. So they can train models, they can create pipelines, and then whatever we do, they will be doing faster, and then they can reach out to more resources at the same time. That way, it will affect us.
Yeah, it's very possible. Yeah, so thank you, Hakan. Is that you?
Correct. You're welcome.
Yeah, it's very weird because I think this hacker also, I think he somehow, I'm not sure if he used your
Yeah,
name.
he used my name because I mentioned his name in the chat, so he started using my name.
Yeah. Yeah, so I guess he used your name, but hopefully without being able to somehow join your Zoom account. So you just used your name. Okay.
Yeah.
Okay, question here in the chat. Is there any way to do decision trees or fault trees in base 3, not base 2? Yeah, so you can do decision trees, not binaries, but I think I read some kind of paper a long time ago. I don't remember exactly, but it seems to me that so first of all, if you have like a three-way split, then you still can convert that into a binary tree. So and I'm not sure why people are. I think there is a reason why they are not doing it. It's just it doesn't have any advantages, I think, in terms of efficiency. But I think it's possible. So the splits are always on, like on what I've seen is on a numeric variable if it's less than something or greater than something, and on oh yeah, I'm asking for a niche application in computation of site diagnostics transformer. So yeah, you probably can search for this, but I think actually, yeah, I wonder if probably ChatGPT would answer much better than I most of these questions you guys are asking. So already replacing me. All right, any other questions? Yeah, Hakan mentioned trees are still very good at extracting rules for rule-based system. Yeah, true. Also very intuitive for counterfactual analysis. I don't see GTP generating those. Yeah, it's true. You guys can unmute yourself if you want. I think it works now for everyone.
For out of curiosity, I was going to compare LightGBM versus TabNet. And then you mentioned that tabnet is much slower. And I was wondering
Yeah.
if there's any advantages. You mentioned something like using ensemble models. Did you have any experience with tabnet? And then was it painful or was it easy to? I know it was difficult. It's difficult to set up the environment for that,
Yeah.
and it takes a long time. So if
I
you have
don't
any
have
experience, I
a
would like
lot
to
of
hear.
experience, but when it came out, I think maybe 3-4 years ago, I tried it out. I have the results on GitHub. So if you go to my GitHub to that GBM-perf, it must be there somewhere so I have a lot of this kind of extra analysis I put them in GitHub issues. So if you search for tabnet, you would find those GitHub issues, and you would find there the code I used for analysis and also the runtimes. I think it was super slow. And then the author of that paper of tabnet at the time has seen my GitHub, and he tried to help me to speed it up, but we couldn't speed it up a lot. It was from what I remember, it was still super slow, and also the scaling of it, I think it's not linear, so you cannot really use it on millions of transactions.
Yeah, thank you very much. That's really good. I'll check your GitHub.
Question from Madeline. Since ChatGPT has the domain knowledge, could you trust it to do the data cleaning? At least the first pass. Yeah, I'm not really sure. So it has this kind of general domain knowledge, but not necessarily what's. So let's say my problem is that I have a data set, tabular data, CSV file or whatever in a database. It doesn't have the domain knowledge related to that application, most likely. You could try to add some kind of domain knowledge, either in a RAG style or just in the prompt. And then maybe you could do some kind of data cleaning, but I'm not sure. So I don't think ChatGPT is very good at if you just copy and paste, let's say a dozen of columns and even thousands or tens of thousands of rows, if it's gonna be able to extract some kind of patterns that what are, let's say, wrong with the data. But it could be easy. Actually, I really like to do this kind of simulations and experiments. So you could create some kind of synthetic data and then something that and put some kind of error in it. So let's say some variable that's distributed normally and then put some huge values that obviously are some kind of error and feed it to ChatGPT and see if it discovers that must be something wrong with that data points. Actually, that's a very interesting question and suggestion. So maybe someone can do that. Yeah. So yeah, Madeline. So basically, yeah, you can create some kind of synthetic data where you add your issue synthetically and then see if it's discovered or not. All right. So I guess if there are no more questions, we can wrap it up. It's almost the top of the hour. So thank you all for especially for the patience in dealing with these spammers. So, and thank you very much for the help in chat, and then that somehow we managed to lock him out. So, yeah, I'm sure definitely next time I will put a waiting room. And actually, I hope to be able to reboot this meetup to do a couple of talks online a year. So actually, I think I have the next speaker. So probably in a couple of months, by the end of the year, we'll have another meetup. So thank you very much and enjoy the rest of your day, guys.
Thank you.